All right, let's talk about custom sorting in Java. Seriously, if you're a Java developer, you know you're going to run into situations where the basic sort just doesn't cut it. This is a skill you absolutely have to master.
Okay, so here's how we're going to break this down. First, we'll look at the core problem, the sorting puzzle. Then I'll introduce you to our two main tools for the job, Comparator and Comparable. We'll pit them against each other, head to head, so you know exactly when to use which. After that, I'll show you a super cool modern Java shortcut, and then we'll wrap it all up with a quick recap. Sound good?
So, let's kick things off with something we're all familiar with. We'll start with a really simple concept, but you'll see how it quickly leads us to a bigger challenge, a puzzle that needs a new way of thinking.
Think about it. Sorting a simple list of numbers in Java, it's easy, right? You've got a list of integers, you just call Collections.sort, and boom, done. It just works, no questions asked.
But what happens when the rules change? What if you don't want to sort by the number's value, but by its last digit? So a list like 43, 31, 72, 29 should actually become 31, 72, 43, 29. See? The standard sort method just, well, it can't do that. It has no idea what you're asking. That's the puzzle we're here to solve.
All right, so to solve a special problem, you need a special tool. A specialist, if you will. So let's bring in our first sorting expert, the comparator.
So what exactly is a comparator? The best way to think about it is like hiring an external consultant. It's an expert you bring in for one specific job. It's a separate set of rules you create that tells the sorting method exactly how you want to organize your stuff, without having to change the stuff itself.
And the best part is, using it is a pretty clear four-step process. First, you create your comparator object. Then, inside its special compare method, you tell it how to compare two things. After that, you just hand your new expert rule set over to Collections.sort. That's it.
Now, the real magic happens right here, inside that compare method. This little line of code, this if imod 10 greater than jmod 10, return 1, that's the whole secret. All we're telling Java is, hey, look at the last digit of both numbers. If the first one's is bigger, return a positive number. And that positive number is the signal for the sort algorithm to swap them. So simple, but so powerful.
Okay, so we've solved our number puzzle. But what happens when things get more complex? Let's level up the challenge a bit. Now, we're not just sorting numbers, we're sorting custom objects that we've created ourselves.
Right, so our comparator trick was great for integers, but what if we have, say, a list of student objects? Each student has a name, an ID, an age, and we want to sort the whole list by age. How in the world do we do that?
Well, if you just try to throw that list of students at the standard sort method, you're going to get a big fat error. And it makes total sense when you think about it. Java has no clue how to compare two student objects. Is it by name, by ID, by age? It's not a mind reader, so it needs us to tell it what to do.
And this is where our second tool, Comparable, steps in. Now, instead of hiring that external consultant, Comparable lets you build the sorting logic directly into the object's DNA. You're basically defining its natural or default way of being sorted.
So you do this by having your class, in this case student, implement the comparable interface. When you do that, you have to provide a compareTo method. And inside that method, you're literally teaching the student class how to compare itself to another student. Here, we're saying, hey, when you need to compare yourself, just look at your age versus the other student's age.
All right, so we've met our two sorting specialists, Comparator and Comparable. Now for the main event. Let's put them in the ring, side by side, so we can really understand their strengths, their weaknesses, and, most importantly, when you should pick one over the other.
Honestly, this is the perfect way to remember the difference. Do you want a third party to come in and compare two students? That's your comparator. Or do you want to give the student the power to compare itself to another student? That's comparable. It's all about whether the logic is external or internal.
And if we boil it down to the absolute basics, this is it. Comparator, the logic is external. You pass it in when you're ready to sort. Comparable, the logic is internal. It's baked right into the class itself.
This table really breaks it all down. The biggest thing to notice is the purpose. Comparable is for that one single natural order. Think sorting employees by ID number. Comparator, on the other hand, lets you define multiple different ways to sort. You could sort those same employees by last name, or by hire date, or by salary. It's also your only option when you're working with a class you can't actually modify, like from a third-party library.
Okay, now for a quick but super important detour.
We've been talking about comparator, and if you're using any modern version of Java, which you really should be, there is an incredibly clean and elegant way to write them.
See, back in the day, before Java 8, if you wanted to define a simple comparator, you had to write all this boiler code. It's called an anonymous inner class. It worked, sure, but it's a bit clunky and hard to read, isn't it?
But now, look at this. With a lambda expression, that whole messy block of code shrinks down to one single beautiful line. The logic is identical, but it's so much cleaner, more concise, and way easier to understand at a glance. It's a game changer.
Whew! Okay, we have covered a lot of ground. So let's take a deep breath and do a quick recap of the most important takeaways to make sure everything really sticks.
Okay, here are the 5 key things to burn into your brain. First, comparable is for the one and only natural default order. Second, comparator is your specialist for all the custom one-off sorting rules. Third, remember you can only have one comparable, but you can create as many comparators as you need. Fourth, and this is crucial, if you provide a comparator to the sort method, it always wins. It will override the comparable logic. And finally, please use lambda expressions for your comparators. It's just cleaner.
So, from now on, whenever you face a sorting challenge in your own projects, you have the right question to ask yourself. Does this data have a single, obvious, natural order? If so, think comparable. Or, do I need a special set of rules for this specific situation? That's a job for a comparator. You now have the toolkit to make the right call every time.